In 2008, Georgetown's drinking water system was in trouble. With water filter technology from the 1960s, the system was no longer able to provide reliable treatment and water storage for the town's 1,100 residents and 1,500 daily visitors. With an extremely limited budget, the town planned to have Frschetti Engineering, Inc. make small, incremental improvements over many years. However, using innovative approaches, Frschetti exceeded its clients' expectations by applying progressive strategies and was able to provide Georgetown with critical replacement membrane filters, a robust and low-maintenance intake screen, and construction of a new secondary water tank, as well as other comprehensive improvements that will meet the town's needs for many decades to come. Delivering the comprehensive scope of work was made possible by Frschetti engineers assisting the town with efforts to obtain American Recovery and Reinvestment Act funds to cover most of the total project expenses. Georgetown now has safe and reliable drinking water for its residents and visitors. The Georgetown Water Project serves as a model for all Colorado Mountain municipalities that have identified infrastructure improvements that must be made before they reach the tipping point.
The Georgetown Water Treatment Facility Upgrades Project not only solved the town's treatment needs, but it solved a system-wide distribution and storage need. The existing facility did not have adequate storage to allow for the tanks and equipment to be taken out of service for maintenance. The most important innovation at the Georgetown Water Treatment Facility upgrade was the combined use of a self-cleaning intake screen as well as ultrafiltration technology. These two components allowed the facility to remove not only large contaminants like silt and sand, but also microbial contaminants such as pathogens. We designed a project that resulted in safe drinking water for the community of Georgetown, and the operators that operate that facility are able to do their job in a safe way without having to go into their facility at 2 a.m. to repair a failing piece of equipment. The lessons that Frschetti Engineering can share with other mountain communities seeking to improve their water infrastructure are to start early in the planning process, understand your technical challenges and your financing options concurrently. A technical solution will not work if there is not adequate funding to put it into place. Working with industry partners such as the Colorado Department of Public Health and Environment, the Colorado Water Resources and Power Development Authority, your engineer, and your community are critical to solving your needs.
Protecting public health and meeting new water quality standards was being strained by an old and inadequate water treatment plant. A lack of local funds would have caused a significant economic impact to the community unless other revenue sources could be identified. Frschetti Engineering assisted the community with securing federal ARRA funds and therefore provided a major economic benefit to the town's water customers. The use of a new water treatment process, in this case, a membrane filter along with a low-maintenance intake system, and the addition of a new storage tank in the distribution system will provide a long-term solution to the town. Longevity, technological innovation, and the use of an outside source of funds would all contribute to a highly sustainable performance index for the project.
Colorado engineers are among the nation's elite in addressing infrastructure needs throughout the United States as examined in our next project. As an operating example of the water treatment processes proposed for the Port Angeles, Washington Water Treatment Plant, URS Corporation engineers brought their client to Colorado. They visited the North Table Mountain Water Treatment Plant near Golden, Colorado, with the operating staff from the city of Port Angeles, Washington, engineers from the U.S. Bureau of Reclamation representing the National Park Service, and the Denver-based Actiflow sales representative. Observing this operating Colorado water treatment plant and talking with the North Table Mountain operating staff demonstrated the ease of operation and flexibility of the recommended treatment processes that gave all involved a feeling of comfort with the proposed new treatment facility.
The Elwha River restoration in Port Angeles, Washington began with the passage of the Elwha River Ecosystem and Fisheries Restoration Act in 1992, determining that the river be restored to its natural condition and ecosystem. Accomplishing this task required the removal of two obsolete hydroelectric dams originally constructed in the early 1900s. When the dams were removed, 18 million cubic yards of sediment trapped behind the dams would be released, impacting the water quality of the current water users, which would cause a major detrimental impact to water quality and wildlife. To mitigate the impending water quality issues and protect threatened fish species, the City of Port Angeles, Washington selected Colorado's URS Corporation to serve as the multidisciplinary consultant for the planning, design, construction support, and startup of a fish-friendly surface water intake structure and two major water treatment plants. The completion of these projects by URS between 2001 and 2010 now ensure a clean water supply for the City of Port Angeles, Washington, the Lower Elwha Clallam tribe, and the threatened and endangered fish species during and after dam removal, which was of paramount importance in advancing the vision of a fully restored Elwha River.
The Colorado Connection, we showed them the active flow plant at Table Mesa out in Golden, which was a similar sized plant, very similar to what we actually installed out in Port Angeles. Got a lot of good ideas from that plant in Golden, which I'll note was largely designed by operators who operate the plant. They were very influential in the processes selected out there, and they applied operator knowledge into how things worked, which we picked up and used to the benefit of our clients in Port Angeles. The tribe, who is the Lower Elwha Clallam tribe, it's located there. It's been their historical location for many years. Their livelihood, their traditions, their culture is tied to the Elwha River. However, the Elwha River has been dammed up since 1910, when the paper companies came in and installed two hydroelectric dams. So that affected their livelihood and their traditions. Even the place they call their creation site was inundated by the river. As a result of the dams, also some threatened and endangered species were further threatened as the breeding and spawning grounds for many varieties of salmon native to the area were eliminated. So restoring that is really the gratifying part of this project. The Elwha Restoration Project serves as a model for the removal of dams, and these are major dams on major rivers, which I think is going to be increasing in frequency. We're already seeing some of that now, and we're getting questions. URS is answering questions from others who are anticipating doing the same thing.
The construction of hydroelectric dams in the early 1900s to provide power to communities and lumber mills also drastically impacted and altered the natural ecosystems on the Elwha River. The dams prevented the migration of salmon and steelhead into their upstream habitats for spawning, and stopped the downstream movement of sediment and wood, which were essential for maintaining the aquatic habitat. These environmental impacts were to be eliminated by removing the dams by 2014 in the largest dam removal project in the United States. Associated with the dam removal was the release of large amounts of trapped sediments that could have a high social and economic impact on the downstream municipal water systems. New water intakes would also have to be designed specially to prevent impacts on the endangered salmon migrations. The overall Elwha River program is designed with sustainability in mind and demonstrates high environmental and social attributes. The subset project for which URS is recognized also demonstrates high sustainability performance in all aspects of environmental, social, and economic features. Environmental benefits are provided in the design of the new water intake structure, which includes features to minimize impacts on both young and migrating fish. Social benefits are provided to the native tribe and community with a reliable water supply that will meet their needs for decades into the future. Economic benefits are provided by effective use of federal funds, multidisciplinary planning of watershed features, and support of homes and businesses in the community and in tribal areas.